Okay, this is the density of this is this one. So what is the pressure? So this is the free surface. So the pressure at point 1 should be equal to pressure at point 2, no doubt. So I'll write manometric equation from 2. So P2 minus rho GH minus PA equal to 0. And what is the pressure at 1? Equal P naught. So from this PA equal to how much? P naught minus rho GH. Look at now again. What is the gauge pressure? Gauge pressure is negative at point A. Absolute pressure will be P naught minus. So the point where you're measuring pressure, if it lies below free surface, the gauge pressure, the gauge pressure will be negative. The point where you're measuring pressure, if it lies below the free surface, the gauge pressure will be positive. What about absolute pressure? Will be P naught minus, will be positive, or it can be 0. Anything. Suppose if you fill up this liquid, if you bring it up to this level, then become equal to P naught. But it can never be 0 here, this one. And therefore, I said like a positive 0, this will be positive 0. This can be positive, negative, or 0. This is called like a manometer. So like this. So definitely the density of this particular gas should be less than that of air, no? That's why we have this particular position. Let's take one more small last and we'll confine this one. Initially, some basics are there. Once you get it, applications all about the mathematics. Applications is all about the only mathematics. Again, we have to go back to mechanics. Nothing will be there of the fluids. Okay, these are the 3 liquids are there. So this will be rho 1, rho 2. So I want the pressure difference between points A and B. So I'll move from A, pressure at A, pressure at A. Then I'll be moving up, no, here. Rho GH1 minus rho GH1. Then, so only this much is what? I shouldn't go for it. Sorry, rho 1 GH1 minus of rho GH2 minus H1 minus rho 2 GH2 minus PB0. Are you able to understand the manometric equation? I'll start from A. Then I'll move up, no? Then gauge pressure should be negative. So rho 1 GH1 minus. So what is the density of liquid? Rho here. So this distance is how much now? The difference in distance will be H2 minus H1. So therefore rho G H2 minus H1. Why negative? Because we'll be ascending up inside the liquid. Then rho G H2 minus PB equal to 0. Like this, we'll get the pressure difference between 2 points. But so like they're in, look at A and B, they do lie in different liquids, no? So like they can have a pressure difference. PA minus PB must be 0, need not.
Sir, it should be plus rho 2 GH2, right?
Yes, sir, it's plus rho 2.
Okay, this one, yeah. Symbols, okay, let me check all rho I wrote, no? Rho 1, rho 2, yeah, fine. Agree this. So like this also, we can write manometric equation, or you can start with PB also. Both one of the same. You can start at B or at A, or PB minus rho 2 GH2 plus rho G H2 minus S1. This should be negative, no? Okay, positive only. Plus rho 1 GH1 minus PA is equal to 0.